Hello everyone, welcome to Computer Science E76. This is lecture 5, Intents and Storage. So last week at the very end of class, there was a little bit of a problem where it seemed like my debug certificate just so happened to expire around the time that it was really crucial for me to be able to compile and then show off some of that stuff from last week. So I do just want to reiterate a couple of the things that we were going over last week, in particular the resources directory that we were talking about and how you can put in a variety of resources into the resource directory, into appropriately named subdirectories within that RES folder, that resource directory, to be able to use them within your application. So things like images, some XML files, of course, for the layout like we've seen a number of times, including in some of the earliest Hello World examples, some string values so that you can use, be able to extract strings and also be able to use that as a way to localize your applications to different languages, to different international languages, and have the OS automatically pick the appropriate language based on that directory, and so on. And so last week, one of the last things that we were looking at was, in fact, just a way to be able to use some sound within your application. And so if we were to actually compile this and plug this into an emulator, hopefully now this time it will actually compile like we actually want it to. And as off screen, there is the emulator. We have this application right here. And so basically this application is pretty simple. It really is just an activity that has an image, a button, and when I click on that button, and hopefully this will be loud enough, it actually plays a sound. And notice that when I actually clicked on that button, it also changed the text of the button. And if we wait long enough for the sound to actually finish, then the text of that button actually changes back to its original one. So essentially, this button is like a play-pause button that we've implemented, but for a specific sound. And so we can use this to play some short sounds. We might, this is not really a technique that you might use to play music, but it is certainly a way that you can play at least some music files. It does allow you to play some MP3s and a variety of other files there. And so how then does this code actually look? Well, this is Intents04, and you can find this in last week's source code zip file, which is, of course, up on the webpage. Subsequent source code examples that we're going to have today is, in fact, going to be from the source 5 zip file, which is also up on the web page now. So if you wanted to download that and follow along, it is in fact there. So if we take a look then at this code, what exactly is happening is a couple of things. Of course, we implement our onCreate method just like we do typically, but within this method, we need to connect to our button that we've created within our layout. Perhaps one of the first things that we should do is actually take a look at the layout itself, just to see that it's relatively simple. It's just that image and that button that we've defined in XML. So moving on, once we have actually implemented that, then perhaps the next thing that would be good to look at is how we actually cause this to play. So we have then implemented the onClick method, because of course this activity also implements the onClick listener. Notice that we have an additional listener here, but we'll describe what that means in just a minute. When we click on that, then we actually need to do something with a player. And so what exactly is a player? Well, keep in mind that we haven't yet instantiated this, so it must be somewhere else that we've actually created this object. And in fact, what we did was do this in the onResume method. So in this onResume method, all we've done is just create an instance of some object called a media player. And a media player can play a wide variety of different file types, one of which is, in fact, some MP3 or WAV files like we've implemented here just to play some short sounds that we have in this case. So here we can see a couple of things. We're passing into it the context, which we've seen this method before, the getApplication context. So we pass into it the current application context, and then also the resource file that specifies the sound. And in this case, we've placed the resource into the raw directory because we don't want it to actually be touched. So in that case, we have placed an MP3 file within the raw directory in the resource folder, and we can access that through our media player. Now, the next couple of things just specify some of the attributes of the media player. In this case, we don't want this sound to loop continuously. We just want it to play once and then stop. So we're going to set looping to false. And also, once it's done, we want the media player to notify our activity that its state has changed. It's no longer playing that sound. And so we might then want to use that as a way of changing that text on the button back to that original text that we had before. And so that is then what this next method does. It sets the onCompletion listener to this own activity. But there's something that's really important about this. Why did we do all of this in the onResume method and not in onCreate? Any ideas? Timing? In what way?
We didn't want to do all of it when we did the initial, so we got to split it up. I'm not quite sure.
So that's a good thought, that perhaps we didn't want to do all of the work in onCreate, and we wanted to spread it out among some of these other lifecycle methods. And that's not really what's happening here. That there might be some cases when we want to do this, but really the reason that we're implementing it in onResume and not onCreate is due entirely to the lifecycle. Because, of course, when we're dealing with the lifecycle, it's only once an activity has been onResumed that that activity is actually going to be at the forefront. It's actually going to be interacting with the user. So in other words, if the activity is paused or if the activity is stopped, then that means that the activity is partially or wholly obscured by something else in front of that activity. And so there's really no reason for us to have this media player loaded, because it's using memory that is not necessary, since there's no chance that a user is going to be able to sort of go below these activities that are covering up our current activity to be able to play the sound. So really what we want to do is only load the media player when we're actually going to use it, which in this case is going to be onResume. And so correspondingly, once this activity has been paused, we're going to implement the onPause method and actually release the resources available in this player, so that once something comes in front of this activity, we're no longer using all of those resources associated with it. And this is something that's very important to do, to be able to clear up some resources, because we are very limited in resources, of course, on these mobile devices. All right, so moving on though, once we have onResumed this, and so of course in the lifecycle that means that once this activity is loaded for the very first time, it does in fact get created and then started and then resumed. It doesn't matter if it's starting from scratch or if it's actually being resumed from a pause situation. We will have then an instance of our media player, and we can then use that to be able to play our sound. Of course, the sound doesn't play initially, it plays after a click, and we can see how that's implemented in our onClick method, where we actually query the media player to find out what is the state. Is it actually playing a sound? If it is, then we want to make sure that that button actually pauses the sound rather than starts another one. Or if it's not playing sound, then we do in fact want to start that sound. So we can see then its behavior. I can actually click on start. It's like it's a play button. Then I can click on the pause button, which actually causes it to pause. And if I click it again, it will resume based on where that sound previously left off. And once that sound completes, of course, we had that onCompletion listener, which means that it's going to allow us to change the text of this button back to its original text. And we can see how we implemented that in this onCompletion method, which is part of that onCompletion listener that we had just a moment ago. Any questions on this? Now, the media player is pretty neat and pretty interesting, because you can then add some additional pizzazz to your application. So if you want to use it, there's of course a lot more options. Take a look at the API documents. They will spell out a few more methods that are available to you and some other options that you can implement on your own there as well. Now, if we move on a little bit, we do actually have some other stuff that we want to take a look at, especially that might be relevant to your project. And one of them is Intense05. And taking a look at this code really implements something relatively simple. We have a UI that's relatively similar as before, and in fact it will play that sound as we had just a moment ago. But now what I have as an option is, if I bring up the menu, which all these Android devices actually have a physical menu button, or it's at least a little soft menu button that's present below the screen or off to the side, we can actually bring up a menu that allows us to pick a variety of options that might actually change how this application works, or perhaps some of the settings within this application. And in this case, we have two options, a tortoise and a hare. Right now, the hare is selected, but if I click tortoise, then some state actually changes, and we can change the image of this application, but also can we change some other state, the sound as well. Now, this is a little bit misleading, because these pictures are from an event called an autocross, where basically they set up a big course with a bunch of cones. People drive around it. And actually, this little car, this BMW, I think it's a 2002, is actually really quite fast. as you can tell by how far over it's leaning. But anyway, this is really just meant for examples that rather than to be an instance of how this actually happens in real life. Anyway, if we take a look then at how we implement this, we do something very similar. We have a layout where we've specified an image and also that button, and we might then want to be able to change that image at a later point in time. Now, in order for us to actually create then all of this stuff, we have a variety of things that's going on. So we have a function. We've implemented a new function called setCar, whose responsibility is to instantiate a new version of the media player and pass into it the appropriate sound that we actually want it to play. Now, another thing that this setCar method might do is also to change the image that's actually being displayed in the layout as well. So we can programmatically change, without having to change the layout, we can programmatically change the image that's actually displayed in that image view in the layout. And so if we just take a look then at setCar, we notice that a couple of things. It accepts which car it is that we actually want to create. Notice that we have created new IDs for each one of them, and we'll see where these came from in just a moment. But we use a switch to be able to define which one it is that we actually want to use. Now, there's a little bit of house cleaning that has to happen at first, and that is that if we actually have an instantiation of the media player, we don't want to create another one, so we'll first release that just to make sure those resources are free before we recreate a new media player with perhaps a different sound file or even the same one, depending on the selection that the user has for that menu. All right, so after the house cleaning is done, we use the switch to determine which car has been passed into this method as parameter. And from that, we can create one of two media players, either one with an early car engine noise, as we can see here. Oops, the same thing all over again, the early car engine, or depending on the other selection, if it was the hair that was selected, we could then use the other sound file. And both of these sound files, if you were to look in the resource directory, are of course in the raw directory there as well. And we can take a look at the images that are in use as well. We place two different images within the drawable directory. We can pick which one is actually used in that image view by using set image resource and passing into it the ID of that resource that we want to switch to. All right, it's so not that complicated, right? So how then does the menu actually work? Well, if we want to implement a menu, we have to implement this method called onCreateOptionsMenu. Now, obviously, this method is not required because you've implemented activities up until this point without actually implementing this menu. But if you want a menu to be used when they click the menu button, then you do have to implement this method. There's two different ways that you can create a menu. One of them is programmatically, and it's very similar to how you would create a standard layout. One of them is programmatically, and another one is defining a menu in XML. Now, I'm only going to demo, in this case, defining it in XML, but you can use this add method as part of this menu object to be able to create it programmatically if you want. But really, if your menu isn't changing within the context of your app, of your task, then perhaps you can just define it statically in your XML file and deal with it that way. So if you do want to do it in XML, then you actually create a new layout file, which I'll show you in just a minute, and you have to inflate it. And inflating it basically just means you're asking the Android OS to read this XML file and to take all of those objects that are within the XML file and actually create real, true Java objects out of them. So there are actual menu objects that can be created and that we've defined in the menu XML file, and that get inflated into actual objects. So once we've actually told the Android OS to inflate this XML file and all of the menus, all of the sub-options and the menus within it, then we notify the calling method whether or not we've properly handled the creation of the menu. In this case, return true tells the calling method that we have in fact created a new menu, and it should use that object that we've just created to display the menu to the user. So then Android OS takes care of the rest. And this is one of those examples where, yeah, it perhaps gets a little bit hard to wrap your brain around it at first because there's nowhere do you actually see where this method is actually being called. It's happening all behind the scenes. But as long as you understand that this does exist and that this function, this method rather, is what will be called by the Android OS when the user pushes the menu button, then hopefully it makes a little bit more sense. So notice here that what we are inflating is this resource right here, r.menu.options_menu. And this is actually found in our resource folder under the menu folder. and we have this XML file called options menu. So very much like we've seen before. And if we actually take a look at this XML file, it's rather simple. Notice that our root element is a menu element. We have two items as sub-elements within, and you can place those to, you can place text and also icons within those. Now notice here is where we've actually created those two identifiers that we used in that setCar method, the tortoise and the hare ID. And we've done this, we've talked about how we can actually create new IDs in XML files, in the resource files, using this @+ denomination like we see here. And it's important because that's how we know which of those buttons has actually been pushed. We have to assign IDs to each of these buttons in the menu so that we know which one has been pushed. We can also provide a title to it and also optionally an icon if we would like. Now there's something interesting about these icons. Notice that we have here @Android and then colon. What we are saying with this is that we are looking at a different namespace entirely. So the Android OS actually has its own namespace, and it has contained within it a variety of icons. Now this is one of those things where it's sort of do as I say, not as I do. It happens to be the case that these icons, are provided in the vast majority of Android OSs, but sometimes they do change on you. Which means that while, yes, you can reference them in your application, you might be able to use some of them so that you can just use pre-made icons and display them. It's really not recommended because it might change in the future. In some future OS version, that icon might change or it might disappear entirely because the OS no longer has a use for that icon if that feature is deprecated or if it's been replaced by something else. But if you decide to live on the edge a little bit, you can actually see some of the list of, or some of the valid drawable resources at this URL here, which is specific to Android version 2.2, but still you can see what sort of things you have access to. So if you want to see a preview of those icons, we can see that one of them is IC menu slideshow, and I can search for that one here, and it is in fact that icon that you saw before just a moment ago. So instead, what I recommend doing if you're going to create an icon is in fact to create your own icons and place them within your own drawable folder and reference those instead. So no longer then would you have this @Android definition, @Android : drawable / IC menu slideshow, but instead you would reference your own drawable icon that you've created and just placed within your drawable folder. That will be a little bit more robust. It will help prevent any sort of problems in the future, but this option is still there if you really want to sort of take a walk on the wild side, I suppose, with your application. All right, so let's go back then to the code. This is that XML file that's inflated by this code that we have in onCreate options menu. Now, once it's been inflated and we've created the menu and we actually display it, the user is most likely going to pick one of those two options unless they happen to pick the back button and just cancel that selection process entirely. In that case, once a user selects one of those items, another method is called this one, options item selected, and it passes to our method, the item that was actually selected. And in this case, it becomes a very simple matter because we've already defined that setCar method. It becomes a very simple matter of us just passing in the ID of the item that was selected, and from that then can we identify which of the two options the user actually wants and then change the media player accordingly and also change the resource, the image resource in the image view accordingly. Makes sense? It's all sort of coming together now, all of the various things that we've taken a look at before. Now we've seen some of the remainder of this source code from the previous source, and that is just the implementation of the button and the onCompletion listener. Those are actually still going to work as they did before to play and pause the sound file and also to cause the button to reset its text to something that we saw before. Now, of course, we are using references to the string file in this case so that we could in fact localize this or change it quite easily, just like we saw in previous examples. But just to sort of solidify this idea, if we open up the strings.xml file, we can see in fact the precise text that we saw in that was used in the buttons as we've implemented in this XML file. So resources then are a very useful way for us to be able to create very robust and different types of applications. Now there is something that I want to point out here, and that is the onResume method. Notice that onResume, what we do rather than create an instantiation of the media player is we call the setCar and we pass into it a default option, which just happens to be the hair in this case. And what this allows us to do is the very same thing that we saw in the previous source code, or in the previous application, which is to create an instantiation of the media player and also to make sure that we have set the image resource by default to something so that we can see something rather than nothing when this application actually loads. But there's an important thing to realize when we're actually dealing with this, and that is that if I decide to close this application and reopen it, 10.05, it's going to reset basically to the default rather than to be something that we want it to be. And so we're going to take a look at how we can then save our preferences and refresh them or to pull those preferences at a later point in time, probably in a few applications when we get to the storage examples in a few apps hence. Any questions on any of this stuff? All right. With that then, let's move on to Intense06. And this now is really where we can start to create additional activities. And there's a couple of very important things that you have to realize whenever you create additional activities. First of all, you're going to have an additional Java file in your package. So notice that down here we have, of course, our source directory, and we have two Java files, not only code6.java, which was traditionally the sort of name that we gave to our single activity applications, but also another activity called thumbsup.java. And both of these are implemented as independent activities. In fact, you can see that this is what the code6 activity looks like, which is just kind of standard. We've seen onCreate in a bunch of times. And the thumbs-up activity also happens to be an implementation of an activity. It's in fact a completely standalone activity, and it is something that we could run by itself in another task, but we are going to use as a completely different window, basically, within the context of our task, of our application. So if we want to see then how this behaves before we actually dive into the code itself, we can compile, run it, and notice that there is this activity. This is the initial activity that's shown, and it says, can you start a new activity? You can either say yes or no. If you click no, it just happens to close this application, but if you click yes, notice what it does. It slides the whole window to the side and it actually shows us our new activity. Now, we've had a lot of discussion up until this point about the activity lifecycle and what that means, about how an activity is started, or rather it's created, then it's started, and then it's resumed before it's actually shown to the user. And then if it happens to be the case that the activity is obstructed by something else, then it's paused and then stopped, or however far down along the lifecycle it actually happens to take place. When we're actually dealing now with multiple activities within our application, we have to pay particular attention to this life cycle, because all of these life cycles are happening, or rather the single life cycle is happening in all of the activities that we have implemented within our app. So in this case, we had our initial activity, which looked like this, and it didn't look like that at all, actually. Let's go back to Intense, is it? Nope, not that one, wrong one. Intense06 looks like this. Then once I click yes, then it goes through that entire life cycle that we mentioned just a moment ago. So that initial activity, when it first started up, went through that entire life cycle, which was to, of course, be created and then started and then resumed, and then it actually displayed this to us. Then when we click yes to actually start a new activity, because the new activity completely obscures the previous one, what happens in this chain of events? What happens in the life cycle of these two activities? So what happens to the first activity that we saw?
The memory gets swapped out as the first one?
So the memory might get swapped out, but what happens is that it gets paused and then it gets stopped first. And then if the phone happens to decide, if the OS happens to decide that it needs to reclaim that memory, then it could kill that activity altogether and reclaim that memory, but not necessarily. It could in fact still be running not necessarily running in the background, but could still be loaded in memory. Right, so they each have their own unique state. So the first one actually had to go through that life cycle to become stopped, right? Because it's been completely obscured now by the second activity. So that first activity was paused, then stopped. And then the second activity went through its life cycle, where it was created, it was started, and then it was resumed. And this is perhaps not quite so important for this very simple example, where there's no data being passed between these two activities, where really all we're doing is just creating a new activity, just basically showing a new window to the user. But this becomes very important when we need to share data between the two and be able to and to be able to pay attention to saving state in each of these activities from one to the next. So how then do we actually cause one activity to create?
Sorry, I didn't get that.
I'm sorry?
Where in the last activity was there a resumption or something? I just thought that there was one event.
So don't forget that in a typical activity lifecycle, even if it's being created from scratch, it still goes through those sequence of events, which is to be created, started, and then resumed. Even if it hasn't been previously paused, it still goes through that same life cycle that we've seen a few times before. Let me bring it up here, 1 second. So it still goes through this same life cycle, no matter how that activity is started, it still gets started by the onCreate method first, then the onStart method, then the onResume method. And whether or not we implement those methods is another issue entirely. We may not actually implement all of them. We just have to implement the onCreate method to make sure that we place the layout within that activity. But really, in the context of this application, which is relatively simple, we may not actually see an implementation of onResume within our second activity. But if we do implement it, then it will be called per this activity lifecycle, like we've discussed before. So it's just important to keep in mind that this life cycle still applies even when we have multiple activities. It's not meant to be overly complex or overly difficult. It's just that this exact thing becomes more prevalent when we're dealing with more activities because each activity goes through its own life cycle depending on the state of the application, the state of the activities that are actually being displayed to the user. So that's really the point of this discussion that I'm trying to make. So if we want to create two activities, or if we want to be able to call to a second activity from a first, there's a couple of things that you have to do. First of all, you have to create your second activity, like I mentioned before. You actually create a second Java file, implement it as a separate and unique activity with the life cycle that it's actually going to follow through. And I cannot stress this enough, there is something that's really, really important that you must do if you want to have more than one activity. Is everybody listening? You must put the second activity or the third activity or how many activities you have in the Android manifest files. I do not want to see any questions on the help board. Why does my second activity cause this thing to crash? I can't understand. You must place it, and every year we always get questions about why doesn't it actually work? And I'm telling you this now because even I forget, frankly, to place the activity into the lifecycle, and it's a silly mistake, and it takes forever to figure out why. But if you do not tell the Android OS that the second activity is valid and part of your package by specifying it within the Android manifest file, it will not find that activity and it will not start it. No matter how hard you try to call it from your originating activity, it will not happen. So what this means is that within our Android manifest file, we're going to have two activities defined. First of all, the code 6 activity, which is the main activity that we saw a second ago, and now this second one, thumbs up. And really, it's just a simple matter of basically specifying this an activity element, and providing to it the name of that activity. Now notice that there's two different ways that we're doing it. One of them is to specify explicitly the entire package name, which this is the package name of this application, net.cs76.lectures.intenso6.thumbsup. Or you can do it implicitly just with .code6. So really, this is just a contraction of the former, but we could type both out equally the same, just so you sort of see that there's two different ways that we can do this. Now notice that in one of these activity elements actually has something called an intent filter, which is a child element in this XML file. And what we're saying with this intent filter, and we're going to see what intents are in just a little while. In fact, the next source will demystify what intents actually happen to mean. All we are specifying with this intent element is which of these multiple activities happens to be the main one. When this application is first opened, what's the activity that the Android OS should open first? What's the main activity? That's all we're saying with this intent filter. One of them is it's the main activity that should be launched, and the launcher, this is the activity that should be launched when we actually sort of run this application from scratch. Okay? Yes?
That .code 6, that can be used only if you have one activity with that name, right? You could theoretically have the same name in different package?
You could theoretically have code 6 name in a different package if you had, so if you had multiple packages within your application and you wanted to reference and you somehow had multiple activities that were all named the same across these multiple packages, then you'd have to explicitly define, of course, the explicit activity that you want in that case. But this is basically just because almost every application that you're going to deal with is going to be a singular package, and we can sort of assume that this Android manifest file is for the same package that we're dealing with, and so we don't necessarily have to explicitly define it as the entire package name. So it's really just a contraction.
I guess I just want to know if there's no restriction on the activity name, right? You could have the same name in different package.
There's no, as far as I know, there's no restriction in the activity name other than it has to conform to the standards that would apply to a Java class file name. So basically, I think that's pretty much as far as I know, the only restriction placed on that. Yes?
How does this all work with, say, loaded multiple applications? You're just a user and bought a bunch of applications, and they're, I guess, all stomping on each other. How's that work in conjunction with the manifest file?
So I'm not quite sure I understand your question.
I'm trying to ask the question correctly. Who updates the manifest file?
Who updates the manifest file? We, as the program creator, update the manifest file.
So that means that if a user's downloading many apps,
Mm-hmm.
then those many apps don't know about each other, and you don't get that kind of control.
To
Return
control over what exactly?
You can't return to the state, the prior state of some activity.
You can't return to the prior state of some activity. So saving state is a separate issue than this. This does not make any guarantees about saving the state of any of the activities that are being displayed to the user. That's actually something that we have to implement ourselves. So if it just so happens to be the case that the user has loaded up the second activity and then quits your app and then goes to some other app and then comes back to your app, how your app behaves and recalls that state is up to you. You have to actually implement that yourself by actually saving some preferences or by remembering the state of that application and then creating the original state at a later point in time. That's.
I guess I'm not getting this thing.
This is like a config, essentially a pre-compilation config file.
Right. So essentially what we are doing here is we are essentially telling the Android OS what activities are that we have implemented within our application and what the Android OS can do with those activities.
Okay.
Now we're being
Across applications rather than within an app.
so across applications we'll talk about in the next example, because it is actually possible to instantiate or to open up activities in other applications, like we've talked about early on. But that exposure gets defined within this manifest file. You can actually specify which activities via an intent could actually be opened up from other applications entirely. But really, this is a simplistic example. We're sort of assuming that it's one self-contained package, that other applications aren't going to know about our activity, that it really has no point or reason to open up our activity. So all we're doing is this right here. We're just saying that these are our two activities. Did I see another question a second ago? All right. So let's move on then to how we actually implement this in code. So we have then a very simple layout, of course, for that initial activity, which, if you recall, was just the black background. It had the two buttons, the yes or the no. I clicked yes, it opened up the new activity. I clicked no, it clicks finish. If I click yes, it runs basically two lines of code here. This one, which is to create a new intent, and then the next one, which is to actually start the activity. Now, how then does the Android OS know which activity to start? It gets defined in this object called an intent. Now, an intent is actually used, in this case, it seems like it's one of those things that we're over-engineering or that we're implementing for no good reason, but an intent can be a lot more than just being able to define which activity it is that we want to start. So just take for granted for a moment, until we look at the next example, that an intent is just this object that we use to define what it is that we want to do, to tell the Android OS what it is that we want to do when we're starting another activity. Now, you might recall that there was that intent filter element in the XML file that specified what the original, or rather what the sort of main activity was going to be for our application, and therefore what the Android OS should open when it first opens up this application. that's sort of relevant to what we are saying here, because an intent is really just this generic object where you can specify a wide range of things, and the Android OS picks the appropriate activity on your behalf based on the intent that you've created. So what that means is that the intent can actually start different activities in different contexts, in different Android OSs, depending on what happens to be installed on a user's device. But we'll see another example of that in just a moment. But this is just a very simple example of how we can create. We want to tell our application that we want to create, that we want to open up a new activity that we've created. So in this case, the class file that we've actually created within our current application, that we want to start that activity. Now notice that we have immediately following that a finish method. And finish, as you know, closes the current activity. But notice that what happened was that when we opened up this application, and then we went to, let's see, we clicked on yes, we opened up the new activity, the original activity isn't actually quit. The whole application hasn't actually quit. We haven't actually told the application that we want to quit. What's happened is that that activity has actually been closed, but we don't actually see that until we hit thanks, until we actually close that second activity. So finish quits the current activity, as you can see here, but it doesn't actually impact any subsequent activities that we've created. If we wanted to come back to this original activity, we could in fact just comment out this line of code, this finish line of code, which means now that when I recompile this and run it on the emulator, what we should see is that I would be able to start the second activity. When I close the second activity, it comes back to the first activity. It doesn't actually close. We haven't actually specified that we want that first activity to be done as soon as we have made a selection within that context. Okay. All right. So let's then take a look then at how we implement thumbsup.java, which is the second activity. And really, hopefully there's no surprises in this activity. It's really just an independent activity where we've created a layout with that image and the button. We've connected to the button, and when that button is clicked, that finish button, then we actually close that activity, and it slides off to the side. It goes to the standard, the same old activity lifecycle that we've seen before, and it shows the previous activity if that's what happens, if it still happens to be running, or it will just close the application if that is the last activity in the stack. Yes?
When you call that method start activity, whatever that is, from the other one,
Mm-hmm.
so after that, the other activity starts right away, or it's going to wait for this method to finish?
So this activity actually has to go through its standard life cycle. So what it's not a blocking method call necessarily, where it's going to start this activity and then it's just going to sort of wait right here at this line of code until it actually returns. It's actually going to say, it's going to say, okay, I'm starting this activity, so I'm going to do that as soon as this is done. So finish is actually saying, okay, as soon as we've told the Android OS that we want to start this application, and I've specified that I want to finish this current one, so it's going to go through its complete life cycle to actually close and destroy this first activity right before it actually displays the second one, if that makes sense.
So essentially, the other one is going to start, its life cycle even before this method is finished.
I don't think that they happen concurrently. I think it might happen as soon as this one has actually finished its current life cycle.
You're saying finish here, but you could do other stuff also after calling start activity.
Right. You could potentially do other things.
You're calling finish afterwards, though, so it's kind of confusing.
Well, what you want to do is finish the activity after you actually start. Yeah. Okay. So yeah, I see why I see the confusion here. So you need to tell the OS that you want, because finish will actually cause the activity to break down. It will actually go through the standard lifecycle steps. So if you finished it first, then it would not go to the next call to actually start the subsequent activity. So you basically kill the whole app before you actually are able to start.
You have to have an app in place for it to call the next one, I guess.
Right. So you have to call the next one, and then you can tell this existing activity to finish.
So the finish and the other activity terminates activity number 2, this finish.
Right. So the finish method only applies to the activity that it's being called in. So we need to have, if we wanted to close both activities, that's why we have two different finish methods implemented, one in each activity. This finish only applies to this current activity, and this finish in the other activity applies only to this one. So we could, if we wanted to prevent either one of these from actually finishing, we could comment out the appropriate one. Doing it here in this case makes it a little bit difficult because, well, I mean, we wouldn't be able to go back to the first activity, I suppose, without the back button. But then if we, like you saw before, if I actually comment out this finish, what that actually allows is for me to come back to this originating activity and continue working with that.
Because I guess one thing that kind of, I think, eliminates the confusion is think about the code running procedurally. So it starts the next intent, and then the next line of code that's being run off the pin. You see what I'm saying? So is that clear?
It's coming back or something.
Well, this activity executes this process, but then just finishes that code, right? I mean, it calls the next line of code, which is a finish this, says get rid of this activity. But it had already said create this new activity.
Yeah, the Android OS you've notified the Android OS that you actually want to start this next activity.
Yeah, so it's going, but then it's still got to go finish, executing the code that you
Right. So because the Android OS has to go through the typical life cycle for this code, it will actually pause. It will actually go through that standard life cycle of pausing it and then stopping it, and so on, within this context. Okay. Now, let's move on. So this then is how we can create new activities for our within our one application. But I mentioned before that it's actually possible to create applications that can call activities from other apps as well. And so you then essentially create this task, whereby a task is just a stack of activities that could come from a variety of different applications. And so this concept might sound a little abstract and perhaps a little difficult to grasp with, but really this is the entire point of Code 7. Code 7 implements just one activity, but from it, can you actually open up a variety of activities that have been implemented by other applications. So if I open up this one, and I have to do this on the physical device for reasons that I'll explain in just a moment, we will actually see what this actually looks like on our device here. So we have here just a couple of buttons. Notice here that there's a couple of different things that we can open. One of them is URL. So for example, I can click on the URL button and pay close attention to what happened as soon as I clicked on that URL button. Oh, this has happened before, and I was hoping that this is, I think, just a caching issue, so don't worry about this too much. But basically what happened was that it loaded a new activity, which is essentially a browser window, and I didn't implement this browser myself, but I passed into this activity the data, or rather the URL of the page that I wanted to display, and it then is able to load and display that page on my behalf. Hopefully it's actually on Wi-Fi. Okay, it is. And so you can see that it's actually loaded that page. And if I click on the back button, it actually goes back. It actually looks as though that activity was part of my program. It actually looks like it was part of my application. And this is why I mentioned very early on that it's important to differentiate between a single application and a task. So this really is then sort of the first concept, or the first time that we've seen this concept of a task in motion, because there are multiple applications in play. There's my application, which you see right here, the one activity that I've implemented. And when I click on one of these buttons, let's try a map instead, it actually looks as though I'm starting a new activity, which is true, and it's coming on top of my current one, but it looks like it's still part of the same program, right? But that's why we're making this differentiation between a task and an application. Hopefully this will load in just a minute, but basically this is just a Google Maps map that should be centered on a city called El Paso, Texas, and well, we seem to be having loads of internet problems at the moment, but essentially then this is what we are doing. So if I go back, we can actually see a couple of different things. I don't have a working data connection. That sounds weird. Let's try Street View. Maybe this will work. All right, so here we have Street View. You can see that we've done that again. Now the reason that I ran this on this device rather than showing it to you on the emulator is that the emulator doesn't actually have Google Maps installed. So if you run this application on it and you actually click on this map button, you'll actually get an error that says that it can't find an activity to start the intent that you'd created. In fact, we can see this very thing if I go ahead and just run it. You'll see, and it will look like it sort of looks like it's a problem with the code, even though in fact it just so happens to be a problem with, it's not really a problem with the emulator, but just so happens to be the circumstances of the emulator. If I click on map, you can see there's a little notification that says the activity was not found. So how do we then do this? What is the series of events that has to happen in order for me to be able to open up one of these activities? Well, in this case, it all comes down to this object called an intent. An intent is really just this object that notifies the Android OS that you want to do something. You have an intention to start an activity, perhaps, for example. And using the data that's contained within this abstract object called an intent, the Android OS decides what to do on your behalf. Now you have a couple of different options. You either can you can either do it explicitly, or you can define exactly the activity within a specific package that you want to run, or you can do it implicitly, which provides the user with some interesting options. And what I mean by that is if we go back to this here, and I click on email, notice that what it does is it actually brings up a menu telling me, and even though my intent in code, it's this abstract concept that I haven't gone over quite yet, but if in code, if I define an intent and I say that I want to send an email, and I tell the Android OS that I want to send an email, what if it happens to be the case that there are multiple applications that could send an email on my behalf, that have defined perhaps some intent filters that actually say that this application, or rather this activity, can accept this intent to open up and send an email on the user's behalf, and should therefore be shown on a list to the user. And that's exactly what's happening here. All of these applications have defined in their manifest file that they have activities that can actually open the intent that I specified in code. And so among these is, for example, Google Mail, which might be the most apropos one, but there's a whole bunch of different things that I can actually use. And now notice that me as the user has the choice. Me as the programmer, on the other hand, I don't get to know what any of this stuff is, because this happens to change on a per user basis. It really depends. Perhaps on your device, for example, you don't have Facebook installed, or you don't have Google Voice installed, which means that this menu on your device will actually appear different, based purely upon the applications that you actually have installed on your device, and which have specified to the Android OS, using that intent filter, which ones can actually be used to respond to this nebulous email intent that I'm talking about. Okay, so this is now the power of this intent stuff, and why there is this additional complexity of having that intent and having the intent filter and actually having to specify an intent before we then start an activity is for this reason. It's so that the user ultimately has the choice. Now again, you could explicitly define as the programmer that you want a very specific activity to open in a very specific package, but that's an explicit definition rather than an implicit one like we've shown you. And in the source code, do we actually give some links if you wanted to explicitly define it? You are welcome to do so, but just keep in mind that perhaps part of the power of Android is that users can uninstall various applications. They might uninstall Gmail, for example, and use a different email application altogether. So if you explicitly wanted to open up a Gmail intent, or rather a Gmail activity, and specified that explicitly in an intent, you could run into trouble in some users' cases, because they may not have that application installed. But if it happens to be the case that perhaps you have implemented in your own application, you want to start an activity that you think that application should be installed on that user's device, perhaps that's a better example of when you might explicitly define it. Okay, but then how then do we actually tell the Android OS what our intent actually should be? So here we just have, of course all of this stuff should not actually look unfamiliar to you by now, but we can see here what happens when I click on some of these buttons. Now the first one, when I want to open up a URL, for example, notice that I have to specify a couple of things. I'm implicitly telling the Android OS what I want to do, and the Android OS is responsible for picking the appropriate program, the appropriate activity to display this content to the user. So the very first one, I'm specifying an action of view, and I'm providing I'm also bundling within this intent the data that I want to display to the user, which in this case is a URL. And so therefore, the Android OS has to pick which application can open up a URL so that the user can view a URL and display that to the user. In this case, in the case of my phone, it just so happens that I only have that one browser installed. So as soon as I clicked on a URL button, it opened up that browser that was installed, or it opened up the activity within that browser that could accept this sort of data and open it on my behalf. Or another option that could have happened was that when I clicked on URL, I might have more than one browser installed, but I checked that little box that said always use that when opening this sort of data, and I selected a browser, and then it's always now picking that on my behalf the Android OS is always picking that on my behalf. Now, I didn't really show you the telephone one, but this is pretty cool too. If you actually want to be able to have the user call you or something like that, you can do that by opening up the telephone application. You can also specify an SMS. Notice that there's a couple of different ones here, Google Voice and messaging based on the intents there. This is sort of the neat power of Android, perhaps over what iOS allows, which is a bit more explicit and a bit more restrictive, perhaps, in the selection of the application that's happening. But of course, this is all very subjective and up to your decision whether or not you like that specific thing. You can you constrain it so that it doesn't show certain apps? I don't know if you can actually constrain the list to restrict certain apps, but I do know that it's sort of what's the obvious choices are to either explicitly define it, to explicitly define one specific app. So perhaps you always want to use that messaging app, or you always want to use that Google Voice app, or you want to have the user to have a choice. But there is a way that you could force the user to always show the chooser by starting an activity and just piping in this intent where you want to create a chooser and you provide into it the data there. But I don't know if there's a way that you can modify the chooser. There might be, but I'm not quite sure in this case. All right, so we have a variety of different things that we've implemented, and I invite you to take a look to see how you can do some of it. Notice that the actions actually vary depending on what's actually happening. For example, action dial, which allows us to specify a phone number. Notice that the URI that we're actually passing in are just sort of URIs that you might type into an A element in HTML, an href attribute in the A element in HTML. When we actually want to have a Google map, for example, we specify it this way using this geo moniker. We can also do Google Street View, and there's a whole bunch of fields that we can specify. All of this stuff you can sort of find in the developer portion of the Android website, and you can see some additional details there as well. SMS and email are all defined in this way as well. And in email, you can really specify quite a few things, like, for example, the type of data that you want to send, the email addresses, and you can specify an array of email addresses. You can specify a subject, the text, so on and so forth, so that you can make it really easy for a user to be able to show you an email address, or to send you an email. If we take a look here, I think there's only one application. There's not even any email application installed on the emulator, so it looks like it brought up just the messaging app by default because the Android OS just decided, this is probably the best one to actually display. Let's see, SMS will work similarly. It actually brings up the messaging app, and you can see that it specifies, or I've specified then the telephone number that the user should try to send to. But map is not going to work. Street View is also not going to work. Telephone should work, even though obviously I can't actually place calls within the emulator. But we can see then how this works in a variety of different contexts among different instances of the Android OS and what happens to be installed on that device. Any questions about any of this? All right, let's take a quick 5-minute break, and when we come back, we're going to put a lot of this stuff together and take a look at a pretty comprehensive example with multiple activities, adapters, a whole bunch of neat stuff. And so I'll see you in 5 minutes. All right, hello everyone, welcome back. So before the break, we were talking about the activity, or the one application that had multiple activities that we've implemented within our one app, and how we can actually create, or rather open up the second activity. And there was a little bit of confusion about when or what the order of operations here is regarding the start activity method and the finish activity method. So I just want to point out a couple of things. That here, what I've done is modified the app slightly to show what happens through the log file, or through logcat, when we actually call each of these methods. So in other words, this is just sort of a poor man's way of being able to determine the timing of each of these things actually happening. So perhaps what I could do, I could make this a little bit better by perhaps including some additional logcat information in the subsequent activity, but I think this actually does an okay job showing us what happens by itself. So if I actually go to this application and I actually load it up, what I want you to pay close attention to, so this is the application that we were looking at before the break, or a little bit before the break. Now pay attention in particular to this area down here, which is the logcat area of Eclipse. And so whenever something actually gets logged, it's going to appear there. What I'm about to do is I'm about to click on the yes button, which is going to call that start activity and then the finish method. And as you might recall, we surrounded it with a couple of logging information here. So before the activity started, we're going to put in the log pre-start, then it's going to be called, then we're going to say pre-finish, and then after the finish method is called, if it happens to get beyond that, it will call post-finish. So what's important to realize is that these methods are, like I said before, non-blocking, and they will actually it will actually perform these tasks, but taking into account the life cycle of the activity. So what we should see then, if all of this information is correct, is that these three should happen one right after the other. Once we've started the activity, it shouldn't block. We should see pre-start right before we actually start the activity. But then once that activity is started, it's not blocking the remainder of this function to be run. So we should also see pre-finish immediately after that. Then once we call the finish method, that notifies the Android OS that we want to close this current activity, this one right here, which means that that is then going to go through its entire finish life cycle. So we will then see post-finish immediately after as well. So if we run then yup, and again pay attention down here to the logcat area, I'm going to click it right now. We can see that the three happen right away. All right, any questions on that? So if you want to see some additional information on timing, then what you can probably do is just to add some additional log messages to see how this is actually happening.
How did you get logcat?
So it just is, logcat is just one of the options among the tabs on the bottom here. It's just the far right. And I just specified the tag that I've defined up here, this tag, and it's just constantly looking through the log for that information. But I could also use the other method that I mentioned before a few lectures ago, where we can actually open up the ADB shell, and then, or rather ADB in a separate shell altogether, and be able to demonstrate it that way. Yes?
Could you put a log statement in the on resume of the second activity?
We could. We have a lot of stuff to go through today. I don't want to go through all of that, but that's something that you can try at home as well to see what the order of operations is there as well. Okay, so let's move on then to Intense 08. So if we take a look at Intense 08, and what I want to do is actually run it so that you can see how it behaves before we actually take a look at how it's actually implemented. It's being compiled and it's being run on this on our native device here. And we can see it looks like this. Basically, this is just a whole bunch of images, or rather thumbnails, that are being displayed. So there's something happening here with this special type of view that's allowing us to have a whole bunch of images on display here. Notice that the layout is essentially just that, but also at the bottom there's a little label as well that's sort of overlaying on top of this. And if I select one of these images, it shows you that image on a full screen activity. As you can see, there's no bar at the top, there's no bar at the bottom, there's nothing happening here. If I want to return to the original activity, I can either hit the back button or tap on the image itself, which causes that second activity to actually close and return back to our initial activity. And from there, we can continue scrolling around and using this. Now, there's a few important concepts from this that are going to be important not only to your exploration of the Android development, but also to the project as well, because there's a few things that, there's been a few questions on the help board that I've seen that we hadn't yet gone over last week, but hopefully now with this example, we'll be able to demystify some of the problems that you guys have run into in your initial versions of NPuzzle. So then if we want to take a look at what's happening here, notice that we have here quite a few Java files in our Intense 08 source code. We have code 8, which is presumably our primary activity, the one that actually shows that grid of images. We have an image adapter, which we'll talk about in just a moment, and show image, which happens to be our second activity. And like we talked about in the Android manifest file, we actually have to specify, of course, the multiple activities that we have, code 8, and then the show image activity as well. And we can specify, in addition, this one attribute that I want to point out, which tells the Android OS that you want this activity to take over the entire screen. Now, the reason that this is important, and this is another one of those gotchas that might be not quite so obvious when you're actually working on it, when you query the Android OS for the width and the height of the screen, that is of the entirety of the screen, whether or not that's actually displaying the menu to you. So in other words, if I were to calculate the width and the height of the screen, which you might have to do when you need to resize your image for NPuzzle, if I happen to be displaying the menu up top, what's going to happen is that that menu is not going to be subtracted out from the screen height or the screen width, or rather, well, the screen height in this case, and so your calculations might then be slightly off as a result. So sort of one of the ways that you can get around this is to in fact just remove that menu altogether and just full screen your application, which sort of makes sense for a game anyway. So that's one way that you might be able to get around some hopefully confusing problems that might result when you're working on NPuzzle. All right, so we've defined all of this in our activity, and now what we want to take a look at is how this is actually implemented. So we can take a look then at code 8, which is our primary activity, the one that is actually going to be launched when this is actually run. Notice that it's relatively simple. There's not a lot of stuff going on. But in the layout, we can see a couple of things. First of all, we have a relative layout like we've defined before, and within that we have a grid view, which is going to be responsible for placing all of those thumbnails into a grid on our behalf. And also it will allow us to scroll within that grid view as well. But then also there's a text view that happens to be floating on top of that with a transparent background so that you can actually create, you can sort of anchor down some additional views on top of other ones in a slightly more advanced layout technique than we've seen in previous examples. So really this grid view then is what's responsible for showing us these images, but the question remains, how then does it actually decide, or how then do those images actually appear within the context of this grid view? Well, if you might recall from one of the examples last week when we used the list view adapter, excuse me, or rather we created a list view activity that was responsible for showing us that all of those contents in a list, and we needed to use this object called an adapter to actually provide a list of those objects to that view for it to know what to display. Now we can use one of the adapters that have been created by the Android OS, like we used I think an array adapter in that case, and we just piped in some string data in an array to that adapter. Or in this case, what we have is something slightly more complex because we have an arbitrary list of images, and this list of images is something that we're going to create dynamically on the fly. And so really then this is something that's going to be useful for us to implement our own adapter. And then what this allows us to do is to provide to this grid view what the image list actually is, what the images are that we want to create, and it will actually be responsible, the image adapter itself will be responsible for actually creating and displaying those images to the user. So to break this down a little bit, let's take a look then at this primary activity. Now this primary activity is relatively simple. We're creating our layout as we've seen many times before. We are connecting to our grid view as we've seen many times before, and we're doing a couple of important things the very end of the onCreate method. First of all, in this first line, what we are doing is we are specifying the image adapter that we want to use, or the adapter that's going to be responsible for providing the data to this grid view. So in other words, this adapter is going to give the objects to this grid view, and the grid view's responsibility is to display those objects on a grid. So there's these two separate things going on. The adapter is responsible for the objects themselves. The grid view is responsible for displaying those objects provided by the adapter on the screen. Then the last thing that we're doing here is we're saying that the handler for when an item is actually clicked within that grid view should be handled by this object. And as we can see in the definition of this class above, we actually are implementing onItemClickListener. And so as a result of that, that means that we have to implement this method onItemClick, and we're going to see how this actually works in just a minute. But you can see a couple of things. We're creating an intent to show that specific image, and we're starting that activity once that object has been clicked. So the interesting bit then, perhaps, comes when we take a look at the image adapter. Now notice that this is perhaps one of the first classes that we've seen that does not actually extend an activity. This class is not actually an activity. This is a class that we are using to help our activity in a different context. So this is actually a separate activity, or not a separate activity. This is actually a separate class that's being called. It's actually an object. So we've gotten so used to equating this idea of Java files with activities and using those as objects. But really this is very much like one of those Java applications that we saw very early on when we did the Java primer. You can in fact create separate classes and use those as objects within your activity. And that's exactly what we're doing here. We're just instantiating, or we're just creating a new adapter class that's based off a base adapter. The reason that we're using base adapters is that that's just sort of the highest level adapter that will allow us, that provides some functionality to our adapter, first of all, but also we can extend that functionality to be specific to what our data happens to be. So again, remember that our image adapter, or this class that we're creating, which I've arbitrarily called image adapter, is going to be responsible for providing those images that I have to the grid view. And the grid view's responsibility, again, is to display those objects that my adapter has provided to it on the screen. So where then do these images come from? Well, I placed them all in the drawable directory, and we can see a whole bunch right here. We can see that we have an icon file, which is just the icon of the application, and also a whole bunch of image files, image_3397, image_3398.jpg, and all of these files have been appropriately named and incorporated within the drawable directory here. Now, this application can actually look at the contents of this resource directory and figure out what images are contained within and display just those images to the user. So in other words, if I were to change some of the files in this drawable directory by removing some of them or by adding some of them in, then without having to specify in an array or somewhere in an XML file or anything like that, will my program be smart enough to be able to decide what those updates were? That's not the most accurate way of saying it, because what it's actually doing is it's every time this application is loaded, it's looking within this drawable directory, finding out which are the appropriate images and displaying those images to the user. So what we get out of that as a result is that if I happen to change some of these resources by either removing or adding some additional ones, I don't have to perform any other modifications. Once I recompile and rerun this application, that then will show us what the changes were to that app. Now, whether or not this is perhaps the best thing to do is another question entirely, because this sort of requires us to recompile this application if we actually want to change the images in this context. But what this does allow us to do is to show this concept within Java called reflection, which is what allows us to take a look at some of the fields that are contained within our drawable class to find out which one of those might actually be appropriate. Okay, so this is a lot of talk about how we actually might implement this, or what's actually happening on the high side, but how do we then actually implement this? Well, this is just a class like any other Java class, so we probably have to have a constructor for it. So when this class is actually instantiated, what I want to do is first to find out all of the images that are appropriate that I want to use within this image adapter. So what are those objects that I'm going to use in this adapter? For that, I have to use reflection. So this is sort of the important bit right here. I'm creating an array of fields, calling it list, and I'm setting that equal to raw.drawable.class.getFields. So in other words, you might recall that all of this stuff, because it's in our drawable directory, gets precompiled by the Android SDK into this r.java file, as we can see here. So we have here a public static final class drawable that has within it all of those images that we had placed within the drawable directory. And again, this r.java file is not something that I modify myself. It's automatically done for me by the Android SDK, or more specifically by Eclipse updating, calling one of the files in the SDK that then does this update for me. So here then, if I actually use this, the class itself has this method called getFields, which passes in, or which creates this array of fields, which contains all of these things right here. And a field is basically just an object that contains, among other things, the names of the fields of this particular class. And that's exactly what we're looking at here. This class has a whole bunch of fields, public static final int fields, that happen to coincide with the name of those images within our drawable directory. So then perhaps we can iterate over this array of fields that we have within our drawable class, figure out which ones are appropriate because we've named them all very similarly. We've started each of these with image underscore rather than say icon.png, which is probably not one of the images that we actually want to display. And we can then iterate over all of those fields, as we can see here, and find out if the name actually starts with image underscore. And so the reason that I'm doing it this way, you can see that one of the things that we're doing is actually counting first the number of fields that we actually have, or rather the number of images that we're actually going to use within this application. The reason that we're doing this is so that I can statically create then, or I can create static arrays. I can know exactly how many indices I want in an array that's going to be responsible for a couple of things. First of all, one of them is going to be an ID of that object, of that drawable object. And second of all, we're going to have a cache, which is going to be very important in a little while. But we have basically these two arrays whose lengths are defined by how many images are actually created or are actually appropriate that for us to display within our drawable directory. So in other words, if we have 20 of these image underscore files, then we're going to create these two arrays of size 20 in this case. Now once we've done that, then we can iterate again through this and actually pull the name, or rather the ID of that image, which, as you recall, that ID is we can reference to actually pull that image resource and be able to manipulate or display that image resource within our activity. We're going to do that over here. Now, in order for us to do this, when we're actually accessing some of the fields within the field object, there's the possibility that it could throw a couple of exceptions. And so this is yet another case of do as I say and not as I do. I'm doing very exceptionally poor exception handling in this case. I'm just catching all exceptions and doing nothing with them. But if you're actually to implement something like this yourself, perhaps what you should do is actually implement separate catch blocks for illegal arguments exception and illegal access exception, which are exceptions that can be thrown by the field object and act appropriately depending on which of those exceptions has actually been thrown. All right, but again, this method is just the constructor of this image adapter class. And again, this image adapter class is responsible for collecting those objects, or rather being the collection of those objects that we want to display in our grid view. So what we're doing in the constructor is determining what those objects actually are by looking at the contents of this drawable directory, more specifically by looking at the fields that have been defined by the contents of that drawable directory, figuring out which of those images is appropriate based on the prefix image underscore, and then creating a couple of arrays and inserting the ID of some of those appropriate fields into one of those arrays, which in this case is the images list. Any questions on this? Yes?
What is that line that's highlighted right there to me?
This line that's highlighted right here. So this, if we take a look at this, so this is a try-catch block just to make sure that this is not going to error out and cause any sort of exception that will cause the entire application to crash. So what we're doing is we're iterating over all of the fields in our drawable directory, or rather in our drawable class here. And if that field name happens to start with image underscore, which means that is an image that we want to work with, then what we are doing is we're inserting the ID. So notice that here list in brackets I is an array that references the fields that were available in that drawable class. And getInt happens to be a method that's implemented by the field object, because this list here is in fact an array of type field. So if we were to take a look then at the field object, we would see a number of methods implemented that they implement, but one of them is getInt. That's because I know that this field, all of these fields, are in fact integers, representing the ID of that drawable resource. So what I am saying with this line then, with this line of code, is that essentially, or rather this collection of lines right here, is that for every field that I have in the drawable class that happens to start with image underscore, I'm going to pull that ID and remember it in this other array that I have called images. So in other words, this images array is really just an array that contains all of the IDs of these image underscore resources that I've placed right there in drawable. That's the final result. Okay? So then in this constructor, I've been able to collect my images. I've been able to figure out which ones are actually appropriate. Now I can actually start to do something with them. So what then actually happens? Well, there's some other stuff, and so like we've talked about before, some stuff actually tends to happen behind the scenes a little bit in the Android OS. So this grid view is actually responsible for taking this image adapter and displaying the objects that this image adapter is going to provide to it. And so it might need to know a couple of things. If it actually wants to know, for example, how many items that this image adapter happens to have, then it's going to ask the adapter how many objects it actually has that it needs to display by calling this getCount method. So this getCount method is a method that we must implement so that we can tell the calling class, or the calling view rather, how many objects we're actually dealing with here. So in this case, this is a rather simple thing because I've already defined that in my images array. I can just return the length of that images array. Simple matter, done. That's how many objects I'm actually dealing with because that's the count of images contained within my drawable directory that apply in this case. Then we'll talk about get item and get item ID in just a moment. But what's happening here is that we now have basically an adapter that knows that it needs to display some stuff. And so what we've seen, what the end result is this. We can see that we have a variety of images. Then it actually causes it to scroll. So it actually is showing us all of these images that we placed within. So basically what we need to do is to have perhaps an image view for each of these images, and that image view is placed in a grid on our behalf. So our image adapter, again, is the thing that is responsible for providing those objects to the grid view that's actually going to be displayed. So in other words, our image adapter is responsible for taking these images, putting them into an image view, and passing that image view object to the grid view, and the grid view is going to be the one that's actually going to place that image view into the appropriate place. So how then do I actually do that? Well, the meat then of all of this actually happens in this method that's called by the grid view called getView. So what the grid view is going to do is that it knows that it needs to display a variety of these objects from the adapter on screen in a grid. And so it's going to start calling this method, getView, and provide into it the position of the object that it needs to display. There's this second parameter here called convertView, which is actually really important, and we'll talk about in just a moment. And also perhaps the parent object that is going to be housing that image view. So how then are we able to do this? Well, let's ignore some of this extra code here, but basically imagine that we need to provide to this grid view that image view that it actually is going to place in the grid. So in order for us to do that, we can define this programmatically by creating a new image view, as you can see here, providing and passing into that view the context, which has been passed into the constructor, and we've remembered in a field variable in this class. And also we want to set some parameters to this view, most specifically what the size of this view should actually be. So in this case, it's going to be about 100 pixels wide by 100 pixels tall. So I don't want to talk about convertView quite yet. We'll talk about it in just a minute. But the simplest example of this is just to instantiate an image view and to place that drawable resource into this image view. So what we might be tempted to do is something like this, right here. This line of code right here where we've created that image view and we want to set the resource of that image view equal to that ID. So recall that images was a list of those IDs referencing that specific drawable object. So really all we need to do is to pull out one of those IDs from this list is then to pass in the position of that of the grid view. So remember that position was one of the parameters that the grid view calls or that passes rather to our current method when we're actually trying to create this view. And we might then be able to load this image. But there's a problem with this. I need to recompile this to actually show you this because I had this compiled just a moment ago with this with this commented out. And the reason that this is very bad, you will see in just a moment. It's going to come up in just a second here. All right, it looks the same so far, right? But notice what happens when I scroll. Why is it so slow? And now, just to make this perhaps a little bit more clear about what's going on, let me instead compile this and run it on the emulator. So it's compiling, and it's going to be run in just a moment here. But any conjecture about what is actually happening with this application? So I'm going to scroll here. Notice it's also very slow. Oh, now we get a crash. What's happening? Yeah. Ran out of memory. Yeah, that's right. So if we were to actually investigate this, we would actually see that I've run out of memory for this application. So why have I run out of memory?
It's not using those thumbnail things that you first set up, the smaller thumbnail size pictures. It's just resizing this gigantic picture.
Right, that's exactly right. So these drawable images are, in fact, I mean, they're not super huge, but they are still a fairly respectable size. In fact, this image here is, let's see, does it show me exactly how big this image is? This image is only a measly 134 kilobytes in size, which isn't very much, right? This is actually an image that I tried to optimize and make to target the size. In fact, look at the image size right here, 426 by 640 pixels. This I actually tried to resize ahead of time to be appropriate for a device like an Android phone. But the problem is using this method right here, set image resource, because what this is doing is it's taking that image and it's just resizing it down to fit within my image view, which I've predefined as 100 by 100 pixels. So in other words, when I have this many images on screen, which in this case is 1, 2, 3, 1, 2, 3, 4, 5, so I have 15 of these images times about 100 kilobytes, we're talking about several megabytes worth of images that are trying to be displayed by this application on screen. And this is not what we want to do. We're trying to shoehorn basically these enormous images, even though they're not that enormous, they're sort of reasonably sized, but for a phone they're perhaps enormous, into these really small views and try to display them that way. So instead, what should we do? And there was sort of a hint in the constructor. I had this thing called a cache. What do you think I'm doing with this cache? What was that? So I'm storing a version of the drawable, but what I'm doing is I'm resizing these images down to an appropriate size that can actually fit within this 100 by 100 pixel box, and I'm caching that image. Because in its entirety, if I were to resize each of these down to that very small amount and then cache them in an array of bitmaps, that, excuse me, that object by itself might be smaller than just one of these resource images. And so then I could have all of those loaded into memory and ready to go and just display them right away. And in fact, if we were to change that code back, re-comment out this code, and again rerun this on either the emulator or also the native device, you'll notice that not only is it not going to crash because it's not going to run out of memory, but also the scrolling is a lot smoother because there is, I mean, it's a lot, let's see, it has to pre-cache some of these, but now it's a lot smoother because all of that stuff has been pre-computed and there's no huge object creation load. There's no huge amount of data that's being passed back and forth. There would be this I/O limitation of trying to load those images from the directory, load 15 images from the directory and try to display them on the screen. So this, then, there must be some way that we can pull this resource file and somehow dynamically resize it. I haven't actually pre-done it. I haven't actually created a secret hidden folder of thumbnails from this list of drawable images, but instead I'm doing all of this in code. And how that works is actually relatively simple. First, I'm going to see if the position or if the cache happens to have some pre-computed thumbnail within the cache. And I'll test that very easily because the cache at a specific position will be null if there happens to be no object there happens to be no image that's been resized and saved into that cached position. Now, if that happens to be the case, that means that I need to generate one of these thumbnails, and I can do that with something called a bitmap factory. And using a bitmap factory, can I specify a variety of options? In this case, in sample size, which needs to be a power of 2, and I'm going to explain in just a minute. But I just want to get through this this concept first. What I'm going to do is ask that bitmap factory to decode the resource, but as it's doing it, to resample this image. And that's what in sample size means. We're going to resample this image so that it's going to pull only every 4th pixel from that resource file and then basically save that as a bitmap, as a thumbnail. So you can see here that we're creating, because of this decode resource, providing into it the resource, the list of resources from our context, and also in this case, the ID of the resource file that we want to use, and also the options that we've defined just above here. This is going to, on my behalf, resample the image, and then we can save that into our cache. And from there, can we then use the setImageBitmap method of the image view and specify that cached object. And this is going to save us a ton of memory. It's going to be a lot faster overall, and it's going to be something that will work a lot better within the confines of the RAM, the CPU, and the I/O capabilities of our mobile devices. So when you want to deal with images that are going to be necessarily relatively large and you need to resize them down to something that's going to be a little bit more manageable, you might want to use this bitmap factory.decode resource. Now there is something that I have to mention about in sample size. You'll notice that here there's nowhere that I specify that the image that I want, the thumbnail that I want, should actually be 100 pixels by 100 pixels. And that's sort of an important differentiator here, is that I might not actually be creating thumbnails that are even close to that size. All this in sample size is doing is that it is reading, or rather what Bitmap Factory is doing via the decode resource method, coupled with this option that I provided here, is that it's going to read this image here, which, let's see, is this full size? All right, this is basically full size. And once it's doing it, it's going to take every 4th pixel. And that's going to combine those every 4th pixels together into whatever the final image is actually going to be. Now, whether or not that actually means it's going to be an appropriate size, I would have to calculate manually. I would actually have to figure out, well, okay, let's see, the size of this image is 426 by 640 pixels. So that means that if I divide that by 4, then that means that the width is going to be about 106 pixels, and the height is in fact going to be 160 pixels. So I'm overshooting it. I'm making it a little bit too big, but in the context of this application, that's okay. I could be a little bit more rigorous about how I'm actually doing this. And in fact, for your NPuzzle application, most likely this is sort of a hint about how you're going to have to implement resizing this image. You can't just load a monstrous image and just resize it. You should first use this Bitmap Factory in sample size. And then, once you get it as close as possible to its final size, then can you actually use an actual resize method to get that final last little bits. And the reason for that is that this is extremely efficient. This is one of the most efficient ways of resizing an image, even though it's pretty crude. It's a pretty crude thing. Now, the reason that in sample size should be a multiple of 2 is because that's how this algorithm is most efficient. It's most efficient if it can take one of these pixels in some power of 2, like every other pixel, or every 4th pixel, or every 8th pixel, or every 16th pixel. This algorithm will actually be fastest. So how then would we be able to take an image like this, one of these image resources, and resize it to actually fit within a 100 pixel by 100 pixel image view? So we'll have to use in sample resize, but as you can see, there's a little bit of math that has to happen here. First, one of the things that you need to do is to first define exactly what this value for in sample size should be. How many powers of 2 smaller do you need to make this image, if any, before you can use in sample resize? Then once you get it as close as possible, then you can do the final resize to get it down to that exact width and height that you actually want. So in this case, for this particular image that we're showing here, in sample size of 4 is actually pretty good, because that gets the width to what was about 106 or so, and then I could actually have some additional code after this that then does the final resize down to perhaps 100 pixels. Whether or not we actually need to make this, to increase the in sample size to 8, we'd have to do some additional math to figure out if that's actually appropriate. But at least for this application, this is okay. Just something to think about for your own NPuzzle app. Now, so this then is how we create this cached position, and or rather this cached thumbnail, and then we can provide that cached thumbnail to our image view, and we can return the image view back to the grid view, and the grid view will then take all of these objects and display them on a grid on our behalf. Right? Not that bad, right? There's a little bit of, there's some leaps of faith that you might have to take, but as soon as you start to get a little bit more comfortable with them, then hopefully this makes a little bit more sense over time. But there is one more thing about this method that's very important to point out, and that is this convert view. It is very expensive, especially in an Android device, to be able to constantly be creating new objects, constantly be destroying old ones. This actually takes non-trivial amounts of time and CPU effort for this to actually happen, and it uses up some additional memory as well. So what this grid view is actually doing is it will recycle views whenever it can. It's not just going to throw them out and expect you to create new views altogether. It's going to recycle old views whenever it deems it appropriate. Oh, so this is still the old version. So we'll have to deal with the crappy scrolling for just a minute. But if we take a look at what's happening here, notice that we have 1, 2, 3, 1, 2, 3, 4, 5, so 15 total image views on the screen right now, right? But if I scroll down a little bit, notice that there's a point when those top views disappear and we get a new set of bottom views. And in fact, it corresponds, it's actually kind of fortuitous that I left the crappy version on, because you can actually feel a slight delay when the new ones appear. Do you see that? Like when I'm scrolling, you can actually see it sort of pauses for just a second. So there's a lot of stuff happening when that new set of views has to be created. Now, one of the things that's happening is that when some old views scroll above and off screen, the grid view, when it calls this method in our adapter, is going to pass those old views to us, and it's going to reposition them back down here at the very bottom. It's going to recycle those views so that it doesn't have to create new objects, so that it doesn't have to create new image views and take even more time than it might take to just recycle those views. So our responsibility then is to be able to appropriately use those convert views and recycle them if appropriate. So if it just so happens that there is no view to be converted because, for example, it is the first time that this application is opened and there's nothing yet to be recycled, it's just it has to place those initial 15 views, then it's our responsibility to create those views from scratch like we've done here. But if it just so happens that convert view does exist, it is actually an object, then what that means is that I can just recycle it. So I don't have to create a new one. I can just specify, I can just typecast that convert view, which was just that parent view, or not a parent view rather, but was this view, and I can make it more explicitly because I know that I've defined it before as an image view above. I can just redefine it as an image view, and then from my cache, if it just so happens to exist, set the image bitmap of that view. And this is an additional optimization that we can use to make it just a little bit faster, just to make sure that we don't have this additional object creation load, which has sort of been a theme in a couple of the applications that we've talked about up until this point.
You need to see it once to take the image back.
Right, so it has to be, so when this application is first loaded, there's going to be absolutely no views here, and you're going to have to first create those 15 views. So that's why we have if convert view is null, it has to create 15 views from scratch. But then from there, it might be able to use these top 3 views as soon as I scroll down. Let's see, let's start from the top here. Very slow. Might be able to reuse these 3 as I scroll down when a new bottom row is actually displayed. In this case, it seems to be that top row will actually still be displayed a little bit when the bottom row is still there. So it's in memory, we probably have 18 views rather than 15, but still it's recycling. You can imagine that there's, as we scroll up even more, now those views are gone from the view, so now the next set down here will just be recycled views. And in fact, if I took away this, and this might actually be confusing the first time you do this, if I actually take this, let's see, how can I do this? If I actually didn't want to reset the view. Now, this might be more intricate, but if I was able to not change the position in the case that it's not a recycled view, what we would see is that we would just have multiple copies of the same images over and over again. It would be very confusing. That would require sort of a major change here that I don't want to take too much time doing. But you would actually see that the view itself is actually recycled in its entirety. So all of that then is how we are able to implement a grid view using an adapter to be able to resize an image, fit it, and to make it a little bit more appropriately sized for our display and for the grid view that we're actually showing. Now, when I actually want to click on one of those images and be able to show a separate view altogether, it's a pretty trivial thing to be able to do. On item click is a method that I've implemented in my activity, and it passes in a variety of things, but one of them is in fact the ID of the image or rather the ID of the item that has been selected, which just so happens to correspond, because I've defined it within our adapter, that the ID of that object should also be the ID of that resource file. So I can pass then the ID of that resource file to my show image activity. And I do that by placing extra data within the intent. So just like we saw before, I create an intent, I explicitly define which class it is that I want to open up with my intent, but I can also put some extra data in key value pairs. In this case, the key is image to display, and the value is the ID of the image image resource that I actually wanted to display. So then in our image view, or rather our show image activity, we would then be able to pull out of that intent right here. We can get the intent that was used to start this activity. We can get the extra data, that's out of that, and we can query for that key that we specified initially, image to display, convert it to an integer because it just so happens that all of these IDs are integers, and use that resource to set the image view of that activity to that image that we've just selected. Yes?
What is the first line where you're calling find view by ID, single image?
Why is this find view by ID r.id.single image? So this is what we've done in the past to programmatically connect our Java code to the objects in our layout. In this case, if we take a look at the layout that we're using in this activity, which is single photo, let's say I have to scroll down here to single photo. So this is the layout that we're using. The image view, the only image view that's there, is in fact provided an ID of single image. So what I'm doing is then connecting to that object, that one singular image view within this really simple activity, and specifying the resource of that image activity, or rather of that image view down here when I'm setting the image resource to that was passed through the bundle, the intent bundle. Then when I actually click on that view, it's actually going to finish that activity and return back to that original grid view. Any questions on this? Yes?
When you change orientation, does the on-creating image adapter gets recycled and called again?
So when you, here, let me recompile this because this is going to be, I'm going to want to use the latest version here. Let's see, it's been modified. Sure, maybe that was a bad idea. Let's do this platform, and we will hopefully see in just a moment. Hopefully I have not disabled the rotation here. But I think in a later example, what we might see next week is that it does actually recreate. It does actually go through a number of the steps again. It is actually going to requery the data here. It's a little bit too quick to be able to see what's going on. We'll see more about this next week when we're actually implementing a similar application, but rather downloading these images off the internet rather than pulling them from the local resource directory. Okay, any other questions on this? Because there's a couple more things that I want to talk about today, specifically regarding storage. Now, if we take a look then at some of the ways that we might be able to implement storage, there's a couple of things. First of all, there's this concept of shared preferences. And shared preferences is one of the ways that you can store some data in your application. It's lightweight, it's key value pair based, and it's one way that you can store a variety of things regarding state for your application. But there's some important gotchas that you'll have to know. Well, not necessarily gotchas, but there's some important things that you'll need to know so that you don't get tripped up about it. You could also read and write files dynamically if you actually wanted to read and write raw data directly. And one of the things that we'll take a look at next week is SQLite, so that you can actually then use some databases within your application as well. Now, when you're dealing with storing data, saving state in your application, the activity lifecycle really becomes a very important consideration when you're creating your application. One of the things that we're going to look at initially is in fact this shared preferences. Oops, I actually did want to run that. So what we're going to do is revert back to that application that we saw just a little while ago that had the different sounds with the different images regarding the cars like this. But if we actually ran that initial one, that intense, I think it was intense 05, you might recall that I actually closed the app, and when I reopened it, it didn't remember which car had been selected. Well, in this case, let's say I change it now from the tortoise to, or rather from the hare to the tortoise, and I quit the app. Well, it's not really quitting the app, rather it's just closing that activity. And then I want to open up storage 01 again. Notice that it has in fact it does in fact save the state. And in fact, if I actually close my app, which by the way, excuse me, this is also pretty important to realize as well, that your app can actually still be running even though the application, or rather the activity, could be closed or stopped rather in the background. I could actually stop this application entirely, reopen it, and it will now completely load it from scratch. And we should hopefully still see that it has saved my preferences before. So if you want to test your application to make sure that your state is actually being saved, I recommend that you actually go through the steps of force closing your application. Because if you don't, it's possible that the app could still be running, even though the activity will go through its normal life cycle and it will be paused and then stopped. It may not actually be destroyed quite yet unless the phone actually needs to reclaim that memory. So the only way to guarantee that you're completely destroying the application as a whole is to actually, well, reboot the phone or to force quit it like that. Otherwise, just by nature of the way that Android works, it might actually still have a process running in the background. So that's an important consideration when you're looking at how you can save state in your application. So how then does this work? Well, the code is largely the same as we saw before, but there is, in fact, one important difference, and that is that we are using the shared preferences object. Now, we're doing a couple of things. We're using we're fetching the preferences in onResume, and we are saving the preferences. We're saving the state in onPause. Why are we fetching the preferences? And just assume for a moment that what I'm doing here is exactly that. I'm just fetching the preferences from these shared preferences, from the shared preferences object. Why am I doing this in onResume rather than in onCreate? I mean, it totally makes sense to do this on onCreate, right? In some ways, because that's when this activity is being created.
Again, you never know when it's going to get killed.
Right, so you don't know, well, first of all, you don't know when it's going to be killed, but also, what if you have multiple activities? What if this doesn't actually get killed at all, but in fact you have a slightly more complex application running, and you have another activity, or you have another dialog that actually opens up in front of that current activity? You could actually restore the preferences perhaps at a different point in time, and I think perhaps the next example will perhaps show this a little bit better. But the reason that we're doing this in onPause is exactly for that reason. We don't actually know when that activity is actually going to be killed. It's actually possible, especially in earlier versions of Android and in phones that are not quite as powerful as more modern phones, for your application to be killed as soon as it's been paused. It's not always going to happen, but it might happen. And so when you then want to save state, it's important to do it in the onPause method. So here then, we're going to do exactly that. And the code, again, is really not all that complicated for us to implement. We're going to have a shared preferences object that we're going to call preferences. We're going to fetch the preferences here in onPause. And what this is going to allow us to do is to be able to create an editor from that. So notice that we have here a shared preferences editor, and we're going to edit then the preferences of this particular application. And because this is pretty lightweight, we specify in key value pairs very primitive data in the shared preferences. You're not going to be able to store objects or anything like that. But you can, one of the things you can put is, in fact, integers. So I'm going to specify a key in this case, and the selection that the user has specified in the menu choice. Or it just so happens to be the case that if it's the default option, it will still allow that default option to be saved as well. Now, in order for this to actually be saved, we have to commit the editor to actually save it. So the reason that this might be useful is if you actually perform some calculations or something and you realize that you actually don't want those preferences saved for some reason or another, you wouldn't actually cause the commit to actually occur. So this is, in fact, a transaction that will occur very much in the same context as, say, SQL transactions, if you're familiar, where it won't actually commit anything until you explicitly define it as such. So with this, we're then saving this data in our preferences, in our shared preferences, which, by the way, and this is sort of important, is just an XML file that's being stored on the file system. It's not encrypted or anything like that. If you decide to create, for example, outside of the context of this class, a game or something where you want to save data and that is going to be particularly sensitive, perhaps the license key to your game or perhaps even worse, the stats of the player of that game, realize that it's being stored in plain text in an XML file on the file system, and if a user decides to root his device, he could actually change the XML file, and your file and your application could be messed up as a result there. So just a warning, it doesn't matter for this class. We don't expect you to encrypt the preferences or anything like that, but just for your own knowledge, if you decide to implement things outside the context of this class, that's an important consideration there. But in order for us to load this data, it's equally easy to do. We just call this getPreferences method. Now notice that we specify a mode here. Mode private just specifies whether these preferences are private to the app itself or can be shared across multiple applications. We might specify that we want these preferences to be world readable by other apps or world writable by other apps if your application needs that sort of flexibility. But perhaps for most of our apps, we will in fact use mode private. Note again that this does not imply anything about the encryption state or whether or not this data is private to the user, but just to other apps. These are in fact sandbox preferences that are separate from other apps as well. Then we're going to fetch the integer specified by this key right here, default car. Now notice that there's a second parameter here, which will be the default option in case that preferences file doesn't exist, or in case that key doesn't exist, or in case there's some error fetching the preferences object for whatever reason. This will be the default right here. So the very first time I opened up that application, that's why we saw the fast car. That's because this was the default when I read the preferences and found that it didn't actually exist. Then, of course, I can go through the normal motions of setting the car here and being able to resume normal operation of this application. Now, if we want to use shared preferences across multiple activities, that's exactly what Storage 02 is going to show us. And this now is a slightly different application that we haven't quite seen yet. But really what this allows us to do is to save state between multiple activities. So in this case, you can see it's a very simple text view with a button. If I click Settings, it actually opens up a new activity that allows me to modify some of the settings here. So I'll remove that. And then I want to show bolded text, and if I save that, we can now see in this original activity how these preferences have been saved. And if I were to close this application, reopen it, actually force quit it, all of these preferences are of course saved because I'm saving the state within this shared preferences object. So you can actually use this get preferences and in the preferences editor within multiple activities in your same application and be able to then fetch that data from one activity to the next if you so desire. And so this might be a good way of being able to save states from one activity and read it in another activity, or even to be able to save state. If we were to make this a little bit more complex as well, we might be able to specify in our preferences file which activity we actually want to open up, and our initial activity, our main activity, when we open that application would then be able to read that preferences file and open the appropriate activity in that case. But this isn't that big of a leap from our Storage 01, so I invite you to take a look at this. This might be useful for you as you work on NPuzzle and of course for other applications that you create for Android as well. And with that, I want to thank you all very much for coming. We will see you next week for the last lecture on Android development. So until then, see you and have a great week.